it, right? It's being recorded.
Okay,
Got it?
got it.
Yes,
Recording?
it started.
Yep.
Yeah.
So can I start?
Yeah, sure.
Yeah.
Yeah, you just have to talk louder.
Okay.
Okay, very good afternoon, everyone. Those of you who do not know me, I am Srikar Velichetti. I am the director for the FedEx Institute of Technology's Technologies and Humanities People for this academic year. Today, we are very pleased to have Professor Heng Xu from the Warrington College of Business at the University of Florida. So people ask me, how did you connect with Professor? So back in 2014, when I was a doctoral student at the University of Arizona, she came there to give a job talk that time, and I was really impressed. Ever since, I have been following her research on LinkedIn. And when Jasbir gave me this job of serving as the director, she was the first one who came into mind. So as soon as I emailed her within an hour, she said, yes, I accept your invitation, I want to come. Right, and that's how we are lucky to have Professor Heng Xu. There's no need to tell about her accomplishments. You can read through her profile. In terms of the talk today, so far when you're talking about regulating AI, we have introduced the privacy laws like the GDPR, and then we're talking about algorithmic fairness, openness. So we have been talking in a siloed manner about data regulation, algorithms, people, so on and so forth. But what Professor Heng Xu is going to talk about is what are the interdependencies among all the stakeholders and how we can leverage that to construct AI systems that are fair and robust. So with that, Professor Heng Xu, I would give the floor to you.
Thank you so much.
Yeah, they probably can't hear us.
Oh, okay. Okay, great. I have the mic here. So thank you so much for the introduction, and thank you for sharing the story. It's really my honor to be here in this fabulous classroom in the setting of theater. That's pretty unique and one of the kind of experience. So thank you. So when I said yes to you, right, it's simply because I'm in a transitioning period of time. I ended up with this semester free of teaching and nice treatment, like a mini sabbatical. So I really feel, yeah, I have nothing to do. Maybe I should, visiting more of making more new friends, visiting some old friends here. Right now I'm just moving from American University Kogar School of Business to the University of Florida. My home now in the Warrington College of Business is with the Department of Management. Before that, I was with the broader community of IT information systems at American University. And before American University, I was actually not in the business school at all. I spent 12 years in the College of Information Science and Technology at Penn State. It's an information science school, and we try to do everything understanding the meaning and value of information. And of course, my research is all about privacy that naturally fits in with the information science program, right? Because privacy is all about people, data, and how you use that data. So I feel fortunately have been engaging with privacy research for so long. For today's talk, I'm going to talk a little bit about history of AI, and hopefully I can convince you by the end of this talk that see the different characteristics of the current generation of AI versus the very first generation of AI that started in the 50s. So AI, the field is AI. AI is not new. And then by visiting the history, a little bit of philosophical lens, I hope I can convince you why my current research, especially I'm still doing privacy research, but why I extended privacy research to looking into the fairness in AI and validity issues. And I will tell you, what do I mean by privacy, fairness, and validity along the line? But when we talk about AI history, and everyone knows that AI has been here since 50s, right? Starting with the famous Turing test, with the big question, can machine think? And starting from then, the AI research community has been working on, this field for so long. And until, 2018, we see a lot of magical things happening in the field, in terms of large language models. We have transformers, GPT is one of them, and Palm, Llama are all different language models. And one of the most popular implementation of these language models are the ChatGPT right now. Every one of us can have access. So I'm not going to go through all the years of the history. That may take another 2 hours, like a movie. I'm not going to see that, but I'm going to let you to see that I use 2 different colors on this timeline, right? Green and red. It means the different phase of AI development. Green means summer seasons. Winter means when the development AI hits a wall, and why they suffer from the long winter where people stop researching about AI. So I'm going to just briefly highlight which years in our histories are the summer seasons for AI, where you see a lot of development in terms of AI, and which seasons are the red colored tones, which indicating winters. So first, AI starting from the 50s, right? Herb Simon, one of the lead, AI researcher, truly believe that the AI researchers can perfectly represent everything in our physical world. So we can specify rules to represent entities, relationships among these entities, and we can specify the rules, right, to express the complicated physical world. That's his vision. And if that was the case, then you imagine that we tell these rules to the systems, and systems can function like each one of us, right? We perfectly know why this object interacted with another, right? We specify these rules, we laid out these rules for the machines to learn, and then that becomes AI. That's the vision back then. But so I want to kind of give you a label that in the history of AI, the very first generation of AI, starting from the year of the 50s, is actually labeled as symbolic AI, where rules are the first order drivers. And the philosophy among AI researchers back then truly believe the physical symbol system that has the necessary and sufficient means for the general intelligent action. And this generation of AI, right, symbolic AI, was the dominant paradigm of AI research from the middle 50s until the middle 90s, which is all based on high-level symbolic representation of problems, logics, and search. And here I give you one example, one of the papers published at the Communication of ACM many years ago in 70s. It's basically representation of a transport systems where, box represents entities and these lines represents the interrelationships. That's how we believe AI should be developed. Unfortunately, this school of thoughts quickly hits the wall. And in the middle 60s, computer science community, especially the AI, right, the symbolic AI community, starting feeling there were cases that didn't work. They can't represent all the complicated physical world with all this, human specified rules. And here is one of my, famous quotation. This is one of the earliest criticisms of AI research that is written by a philosopher. He just didn't, he wasn't convinced by that movement, right? He said, our everyday coping cannot be understood in terms of rules or in terms of responses to the fixed features of the context. He just didn't believe in that handcrafted rules can represent the world. And of course, computer science community back then in the late 60s also take these criticisms and rethink, right, why it didn't work. And they kind of convinced saying that, yeah, we can't specify the relationship, interrelationships, and all these rules to represent everything in this physical world. But how about small domains, right? Expert systems in small domains where we have this rich expert knowledge, right? And that signify a little tiny, followed by this red, right? This winter, followed by a little bit green color tones in the history. That signifies a huge increase and development about what we call expert systems in the 70s, right? People give up the idea in terms of developing a huge giant system represents our physical world. And they felt, okay, maybe we can do small scale systems building on those handcrafted rules simply based on a simple and narrow context. that we see the history expert systems literature that has been fast growing. So that greenish, time period of time signifies the expert systems taking off and a lot of research into that. But when we hit to the period of late 80s, the AI research community fell, no, we fell again. They realized that even for the small scale expert system where we believe experts has perfect knowledge about why this happens, how this system function, what are the rules, right? But still they felt these AI built on these handcrafted rules couldn't learn a new rule on their own. It broke when it encountered a weird situation that wasn't specified by a human subject, by a human expert. So that when that becomes a common understanding, that signifies the fail of the first generation of AI. So in the early 90s, all the federal government agency in this country, in the United States, withdrew funding on AI. That signifies a long winter of AI development until 2010. So the year of the 2010, what happened? I think we are all, know what happened. That's the time period of time where we talk about, high performance computing, big data becomes a reality, right? And that empower a new generation of AI techniques. They give up the rulemaking instead. They're based on huge amount of data. They do statistical machine learning. That signifies the current generation of AI we are current now. Deep neural networks are known to be the universal approximators capable of representing, arbitrary complex functions, giving sufficient capacity and sufficient data. That's our belief system now. So what I want to show to you is basically this fundamental philosophical debate or the experiments that are happening in the history of AI, where symbolic AI were all about specified rules by the human experts, right? Handcrafted rules, and we force those rules to the systems. But now we give up on that because we tried 30, 40 years and we realized we failed. So now it's completely new thinking. We give up on rules. We just let data speaks. And again, here is another graphic representation of my understanding of different philosophy of these two generations of AI. The first generation of AI, the symbolic AI, we assume experts understand the truth and how everything functions. We specify rules, we enforce to those systems, right? Expert systems is the peak season of the AI development in the first generation of AI. So what I put it here is that we assume we know ground truth, we build models about that. What's new today? We give up, we walk away from defining ground truth. So here, ground truth and the models, I put a question mark. No one knows whether we are getting to the truth or we are far away from the truth. What we are trying to do today, not we, it's the deep learning research community, is this basic definition, how they define machine learning nowadays, is to just maximize the log probability that the model assigns to the observed data set. So observation here represents giant amount of data we have now, right? We're just trying to build models to approximate the observed data set for the purposes of prediction, right? When the new data come in, the models learn enough from the observed data so we can do perfect prediction. That's the current movement of AI. And what I'm talking about is that I want to share with you some interesting examples about this generation of AI. This generation of AI has some interesting phenomena where, some people called unintended behavior, other people called emergent behavior, that we fail as human beings, we fail to explain why the machine behave that way, right? They have some weird things because we never specify rules to these algorithms and instruct them to behave. So we let them behave, we let them memorize the data and analyze the data and, derive the intelligence on it and so on. So sometimes it might be, some very weird pattern happening. Like this is a famous example. And to us, human eyes, I think all of you would agree that all these three pictures are stop signs, right? We all agree upon on that. But interestingly, so the very first one is an image of stop sign. And then the second one is one of the smart graduate students from UC Berkeley. They printed a thin slice of, you can imagine as a plastic layer or whatever, but that thin slice of the plastic layer lay on that stop sign has certain signal that to our human eyes, we see nothing, but those are the smart tricks to fool the machine's eyes, to fool those image recognition algorithms. So when they did that, right, we can consider as a cybersecurity attack, and they run this image with the latest image recognition algorithms, and the algorithms return the results as speed limit 45. So this group of smart graduate students successfully attacked this image recognition algorithms. And here's another example. It's just, they kind of play the trick again, put some stickers on that. But then if you think, if we are human beings, you see this, you will stop your car, right? But then to those self-driving cars, those algorithms actually recognize this as lane end. So this is an interesting phenomenon where it demonstrates what I said, right? That gap between ground truth and models. And it's so interesting that the ground truths to human eyes are so clear, they are stop signs. But to these machine algorithms, it's not that clear. And smart graduate students can actually fool the machine's eyes. So this is just one example. We're showing you the current limitations, some of the limitations of the current generation of AI techniques development, right? The ground truth and the AI model. There might be gaps. There are no clear, links, right, from the machine's perspective. What I try to argue today is that I truly believe in the deep learning community that they will gradually, correct these, right? They will learn, and the machine will learn and to have, hopefully one day, have the true intelligence, right? Have the true capabilities as we, how human eyes recognize, or the accuracy can be 100% aligned with human eyes. And I believe that AI researchers still focus on that part, improve the accuracy of prediction. They try to improve the models to better capture the observed data and approximate data. But I felt, I'm not doing algorithm development for that community. I care about how we as the users of AI systems and utilizing these advanced techniques. And I believe that we need to attend to these meanings of AI models, which means that this question mark here, the ground truth, the gap between ground truth and AI models matters to me, because without understanding this, I can easily have frustrations at question marks on privacy. For example, I don't know how my data is used by machine learning algorithm nowadays. And also we see, almost like 9 years ago when Amazon first introduced AI hiring systems, in their own company context, they actually show discrimination against women applicants, right? We all know that famous case. And that also shows the fairness question mark, because we don't know, right? That because of, I attribute to the gap between ground truth and the AI models. And later on, I will also show you some of the interesting behavior we observe, where I label it as a validity question mark, where we show that what we think as human operators or users or designers, what we think or assume we are asking AI to do may not be what it is actually doing. So I'm going to just give you 3 different kinds of examples. That's the 3 parallel stream of research I'm still doing. no matter where I am, you know. So that's why this morning I even forgot to change my institution. Nowadays I'm so into these three questions that are surrounding on privacy, fairness, and validity. And fortunately, they are all funded by different funders and companies. And we also produce gradually, slowly, produce some papers. I'm going to briefly touch these 4 or 5 papers I listed here. I don't have time to go through all the details, but hopefully everything I talk about here will give you a certain kind of interest and curiosity to read our full papers. So let's look at privacy. And some of my friends here knows that I'm a privacy researcher for the past 15 years. And I have been engaging with privacy research from all different perspectives, consumer perspective, technical perspective, data, and also organizational practices. And here, you know, I really like timelines. I visualize the privacy literature through also another timeline. I'm not going to go through it. It's another, probably I can spend 2 hours just on this. But I can briefly, you know, share with you that the most classic definition of privacy starting from Harvard Law Review article published in 1890. Back then, the Harvard Law Review, that article, Warren and Brandeis defined privacy as right to be left alone. That actually signifies the very first classic definition of privacy. And then we see a lot of, you know, literature that has been published about privacy from consumer control point of view, from organizational data practices point of view, from philosophy approach where privacy defined as a boundary and think about privacy violation as boundary violation and so on and so on. And what I'm going to just share with you is also corresponding to the deep learning revolution. Let's do a cutoff point around the year of the 2010, okay? We know that 2010, we had big data, we started having the deep learning, you know, empowered AI revolution. And how about let's take that look to looking into privacy literature to see what happened. What is there any kind of change happening in the privacy literature? Do we still talk about the same concept of privacy before 2010 and post 2010? So I did another analysis. It's all the case and news analysis, all my opinions, right? And we published it as an editorial by the MS Quarterly last year. And you can refer to my paper there. But here is the most important part, where if we pass the literature before 2010 and post 2010 about privacy. So before 2010, every single discussion about privacy, either in the consumer marketing literature or technical community or the courts or the lawyers, we all talk about data flow and data practices. And data practices start with data collection, data processing, data storage, data analysis, data joining, data sharing, right? Anything, any action about data where that triggers certain question mark, we may lead to a privacy event. Sometimes could be an outcry, right? Or we observe. So in that editorial, I actually give several, I cited several classical privacy outcry that happened in the public eye. And one of the most interesting case was because of one of the computer science professors' famous study. What she did, Professor Sweeney, did it in the year of 1997, was just simply to link 2 public available data sets. One is the voter registration list from Cambridge, Massachusetts. And then the other public data set is the de-identified medical data of that state, employees of Massachusetts. And when she joined these 2 public data sets together, she successfully identified the medical profile of the then governor in that state. That triggered the huge discussions in the context of healthcare privacy. And that even triggered the redefinition, right? The HIPAA revised the definition of personal identifiable information in the history, thankfully to this study. And Professor Sweeney continued on. on this, looking into how we may join public available data to better re-identify people's, identities, just simply from public data set. And she published another study in the year of the 2000 without this machine learning AI super powerful technique. It's simply just data joining. And she found that she actually successfully showed that 87% of all Americans could be uniquely identified simply using 3 types of information: date of birth, gender, and a zip code. See how commonly we can share these 3 types of information on social media nowadays. How many of you, went to the Gap store when you finish buying, a pair of t-shirts, right? That salesperson may ask you, what's your zip code? Most of people will just honestly share their zip code. Sometimes when they face me as a customer, I say, no, I'm not going to share with you. And they feel I'm the weird person. I'm not sharing because gender, they can easily tell. And date of birth, they can infer from white page and a lot of places, Facebook, I may have birthday wishes from some of you that accidentally release my birth date. And some of you like Google my name on whitepage.com, that exactly shows my accurate age. You're adding these together, you got my date of birth. And then you see, you can easily tell my gender. And then you ask me my zip code. If I tell you these 3 information, although you look at separately, nothing sensitive. But when you combine them together, the computer science professor can perfectly identify you in a unique way. And so back then, right, when we talk about without machine learning revolution, when we talk about all the controversial cases that happen in public eyes, we can always attribute what are the problems there. So HIPAA's definition of personal identified information got revised because a computer science professor joining the 2 public available data sets. So we attribute the cause of this privacy event is because of the action of joining public data sets. And how we remedy that situation, we change the law definition of personal identified information. So the healthcare providers won't easily share some, of your date of birth, zip code, right, to the healthcare researchers. We try to hide those information because of that study. And then we address that privacy concerns. That's how we treat privacy. Before machine learning revolution, I thought I understand every single thing and every single privacy outcry. If you spell out, I can perfectly explain what's going on. Is it because we overly collect the data and we accidentally share it? Or we process in the data in an unintended way that we identify more individuals out of that data set? Or because we store some data in a place that is not secure, or we perform certain analysis, accidentally share certain statistical attributes so that we accidentally leak their identity, or we already share the data, or accidentally. So every single privacy outcry that happened before the year of the 2010, I can perfectly point it out, right? Which part of the data processing problems we make mistakes. That's why we lead to this privacy outcry or question mark or scandal. But I felt after 2010, I can't explain a lot of things that happening in the public's eyes about why people have privacy concerns, or why or how. I can't even explain how data is used anymore. The reason is because how is my data used by AI? I mean, this AI, the current generation of AI is a very hard question. Here is just a simple example of what may happen, in the context of social media, where, Facebook can perfectly, for example, I'm just making up this example, Facebook can perfectly predict what I may like without collecting data from me. Why is that? Because of the power of machine learning algorithms. It's highly possible and feasible for social platforms, right? To just collect data from other people who look like me. By looking like, I mean their algorithms analyze, my behavior similar to this XYZ profile of with other 1 million of users on their platforms. So they don't need to exactly know who I am, what color of dress I'm wearing today. They don't need to know anything from me. They don't need directly collect any data from me, but simply leveraging their learning algorithms, learning power, they know what I may like. They can predict, right? Because they got so many data from people who look like me, who share certain common characteristics with me, who share certain preferences with me, and they can show me those personalized ads with such a perfect accuracy. They can trick me to buy it. And in that case, think about this. If we still use that traditional data flow framework to analyze my complaint of possible privacy invasion on Facebook, Facebook have perfectly deniability. They can say, look, I never collect data from you. The fact that you feel you're intruded is just a statement that can praise the accuracy of our learning algorithms, right? Because we accurately predict what things you may like, you may click without collecting data from you. We're just collecting the other 1 million of people who exactly look like you, think like you, who give us the consent about collecting data, but without, just without using your data, we can predict you. Who can tell? Right? We're talking about, I think there is another emerging community talking about machine learning. It's extremely hard how you can do that. How you can forget the influence of my data on your training of your algorithms. Nowadays, with this generation of AI, privacy becomes such a tricky question because, if you feel you are violated, and the company can perfectly say, now I'm deleting your data. Okay, this is the way I, satisfy you. Do you feel satisfied? But then how I can verify my contribution of my portion of data, that part of the influence on your machine learning algorithms, can you delete that? Which means that can machine unlearn everything from my data? If they cannot perfectly unlearn everything after deleting my data, then deleting my data as an excuse to sacrifice my privacy desire is an illusion, right? You can delete data, but my influence and my contribution to your algorithm is already there, unless you can perfectly unlearn everything when you delete my data out of your original data set. It's such a hard problem. And some computer science professor from UPenn, they're working on that. They actually coined a term called machine learning. They try to achieve that. Now it's just mathematical proofs. No one actually has a physical way to unlearn the influence of learning algorithms. So that's how I say we really need to rethink the notion of privacy. If we still hold that data flow version of privacy concept, then very soon, when AI is everywhere, when machine learning algorithms is everywhere, we have no privacy discussion because they don't need my data in any parts of the data flow in their products. So what we argue in that article is that the whole privacy research community has to shift it from data-centered view to knowledge-centered view, which means that we have to regulate the knowledge inference to prevent harmful outcomes instead of just simply regulate data flows in the past. So before 2010, every single organizational privacy discussions, every single piece of privacy laws all talk about organization collecting data from me. And then they send certain targeted ads to me, I feel violated. And the way of correcting it is to cut the link, right? But now we don't have that link anymore. So that's another kind of topic. We put it in this very short article, and everyone can perfectly understand, including undergraduate students, and talk about the future of privacy should focus on the knowledge-based concerns. How to do that? I don't have answers. Hopefully one of you will come out some smart research designs and some solutions to address this. So that's just the first piece of sharing of my frustrations, my research questions with all of you about privacy. And next, I'm going to talk about the fairness piece. And the fairness piece, what I'm going to talk about today is actually a paper we just published at Personnel Psychology in terms of the context of AI-based hiring systems. Instead of going through a lot of boring details in that paper, I decided for this talk, I'm going to use some of my life examples and to illustrate the research findings we perfectly find in our research project. So essential problems we try to work in that project, right? It's not that we're going to develop a breakthrough AI hiring systems to fix, to address the bias or fairness issues. We just work on these simple problems, the specification problems. What this is a problem? This is a simple problem of defining the behavior that we would want to see from AI systems. So just address this simple question. How do we state what we want to AIs? It turns out to be extremely tricky and hard. And this is one of my favorite examples. I think perfect match with what we discover in our paper. So you can read our papers there. And this is, Rubik cubes, right? Everyone knows Rubik cubes. And if I walk now with Rubik cubes and ask all of you to play it, everyone knows the goal is very simple. Make each side with one color. And I don't need to specify more procedures, and everyone knows, right? So now imagine everyone get a Rubik cubes, you will start playing with it, right? That's it. And then maybe at the end of 20 minutes, we will see, who won the game. I remember last year, my younger son is just 5 years old. That was the first time I introduced this to him. And I haven't talked a lot about how to play Rubik cubes because I'm so familiar with this. And I even forgot how to specify. I just say, make each side the same color. And he ran away. He went to his room and bring a paintbrush and the paint colors and say, Mom, this is so easy. I would just use paintbrush to paint each side with the same color. And I was, oh my God, I never think this way. Does this count? If he paint each side with the same color, right, within 5 minutes, do I count this as a fair outcome if I judge the same Rubik's cubes with my college students? So what we found actually in our examination of AI-based hiring systems, we found exactly the same frustrations and same questions, is that AI sometimes, if we didn't specify the task with the exact outcome we want to deliver, sometimes we already forgot, right? Because human to human, we have this so-called common sense. We know that I don't need to tell you, okay, how to play Rubik cubes because you have to, just based on the movements, right? If you paint each side a color, no, that doesn't count. Or if you disassemble all the blocks and reassemble them together, that didn't account. Sometimes I'm so familiar with this, I even didn't specify all these details, right? The same happens with AI systems. We observe that when designers try to design these systems, because they are so familiar with the context, they simply put the goal there, make each side the same color. And of course, the AI will maximize all the utility function to achieve that goal. And the way to achieve that goal deviates from the way we imagine or we assume they achieve the goal. So the same question is here. It's just like my 5-year-old. If AI got to the solution by doing this, using paintbrush to paint each side the same color, yes, the checked, right? It's much faster than you use the multiple movements to get there. But do we count this as a fair outcome? That's a question we don't know. Because, if we encourage creativity, I probably give some credits to my 5-year-old. But then if I talk about in a classroom serious, formal learning context, I really want the college kids to play it through multiple movements, use their brain to figure out this puzzle. Then my 5-year-old solution, I wouldn't say, no, I won't count this. Yes?
I like this thought. It's very interesting. But the thing is, people who work in AI in business and industry, they don't know how the AI system works, even working of AI. So explainability and interpretability are the fundamentals to solve this issue of whether it's privacy or fairness, because all the algorithms are guided search. They try to match, pattern matching and all this. So biasness is inherent. So now where you put the biasness, that's the interesting question. Is it on the gender or is it on some other issue? Thank you.
Thank you for the comment. That is exactly, our struggle is, as you see from this talk I give, I provide less solutions. I'm just honest sharing. A lot of questions we observe from our research, and I want to share broadly with, the research community. So hopefully someone one day would come up with a smart solution to solve the problem. So back to this example, I believe nowadays to ensure that AI systems behavior aligns with human operators or human designers' true intentions is actually extremely hard. And often AIs are just trying to optimizing based on the poorly specified problem function, utility function, or goal. And that creates a huge challenge in terms, we talk about a human AI collaboration, right? The problem specification, that's about how to define a task for AI to solve, is actually a huge challenge, I think, right now. And also, I want to give you another example. It's also happening in my household. It's talking the exact same thing that match and align with our research findings, but I think these lively life examples probably make people think more, right? Rather than going through those boring scientific details. So this is another example. In my household, I hire my 9-year-old to clean the house. And we also have these kind of robotics cleaning tools in our house, and he can use, right? So think about what these automatic solutions are good at. These machines are so good at clean the areas under the couch, under the bed, where my 9-year-old really hard for him to reach, right? But what are these, machines cannot reach or is so hard? Are these corners. They can't reach that corner. It's so interesting, right? Because, you would think they can even reach under the bed, under the couch, to tiny areas, but they just can't make the turn in those obvious areas where they have dust. So my 9-year-old, now the clean task is very easy. In the past, without these machines, he has to clean the whole house, right? But now with these machines, he only needs to hold this handheld device to clean the corner. It's so easy. It's so efficient. But to me, do I still pay $20 to him? How I can assign credits to machines and to this 9-year-old? Is it fair to give him exact same amount of money without these machines' help versus with the machines' help? And it's also amazing from a design perspective. Some tasks, like clean the corners, are so easy, even for a 9-year-old, but it's just so hard for a very advanced machine to do it. So that indicating another area we try to work on is called AI-human collaboration. We should identify those problem space or the task definition space and easily identify those tedious tasks that are so easy for machine and AI to do. But then there are so many tasks like clean the corners that are so easy for the human workers to do, but so hard for the machines. If we can align and assemble a team in that way, it's a win-win situation, right? And instead of 2 hours clean for my 9-year-old, it's just now 5 minutes. You just need to attend to the corners. But then some other question would be emerged as a society, how we assign credits to this AI-human teams. Do we still assign the same credits as if we employ the 100% human teams to do the same task? That's other ongoing debates and questions. That's not just the design part, that's also evaluating team performance and so on. So that's another area we're working on, and we have the papers I listed on the on that slides. But this is just a very interesting kind of consider as a movie trailer that you probably give you enough interest that you can read the papers. Probably I stay this for so long, my slides stuck, and I need to probably just do a little bit. Yeah, it kind of interesting in a way that, okay, I think it's back. It's back now. Yeah, now it moves. Okay, so last piece. I would want to save some time for the conversation. The last piece is about, I want to give you some policy implications. I don't want to like just blame that, you know, policy decision makers nowadays, they don't understand anything about tech. How would we trust that they are going to, you know, design a law or regulation, right? But then I want to show you some other parts of the discussion that sometimes it's really hard for you if you want to like come out one size fits all type of guideline frameworks or regulations. And this is another example. A recent paper we published at Management Science simply zoom in on one tiny requirement in the GDPR. And I think everyone knows GDPR. And I hope that after this case, you know, showing this case, you will understand why I put 3 circles there. Later, I will kind of show you how hard it is to make a decision to satisfy these 3 goals, which are privacy, validity, and fairness. So this study exactly shows it's extremely hard to have 3 beautiful goals align with each other. And this paper shows sometimes these beautiful goals conflicting with each other and how we make those trade-off decisions in what kind of context. So this is exactly quotation from GDPR. And it says that the principles of data protection should not apply to anonymous information, namely information which does not relate to an identified or identifiable natural person or personal data rendered anonymous in such manner that data subject is not or no longer identifiable. What does this mean? You know, you all know that GDPR has a lot of requirements, right? For privacy protection, you need to give the consumers choice, options, consent. You know, they have to click a lot of buttons to acknowledge that they know you are setting cookies on their computers and so on. All those tedious principles. But if you say the data I collected are anonymous, never collecting to any natural person, then you can walk away from all those hundreds of requirements, right, to comply to the law. So GDPR also incentivized the whole market, right? All different companies to jump in to use anonymization, to anonymize their data, so that this is such a fast way to comply to GDPR. As soon as you say, I use anonymization techniques in my data set, I never store any identifiers pointing to any natural person's identity, I'm fully compliant. And I don't need to design all these popping up windows, to have consumer consent, because I have anonymous data. Very simple, right? But when the authors of this requirement, when they put together, they never think about how to anonymize the data. What are the ways to anonymize the data? They never think about that. So this is a case where we just try to apply different kinds of data anonymization techniques to a very valuable data set in the context of healthcare, and to see what happens. Is that all the data anonymization techniques are all the same and leading to the same outcome? Or they are changing the underlying data distribution in different ways that may have some unintended outcome? So our research were driven by this simple question. If all the organizations are jumping to this data anonymization technique in order for the fast compliance to GDPR, could an organization level one-size-fits-all solution to data protection incur different impacts on different individuals? We often think about data sets at the system level or organizational level. We never zoom in to say, if I apply this data anonymization to this whole data sets that collected from each natural person, right? Each one of us maybe in the data set, we do that all the data treatment. What kind of impact would it have on each one of us? Does that impact actually lead to the equal outcome when the analytics team build data analytics products based on those data sets? So it's a very simple question. So we did it in a very simple way. We're looking into all the available data anonymization techniques on the market, the most popular ones, right? And then we realized that, okay, there are roughly two types of underlying techniques. We can characterize almost all the data anonymization techniques in these two groups. One is represented by key anonymity, one of the most influential data anonymization technique. Basically, what they do is to do data removal, which means that in this data set, any identifiers that can lead to name, age, race, they all remove that. After that data removal procedure, they release the data set to the health researcher, or sometimes by law, they even release to the public. So that's the data removal procedure as one way to anonymize data. And another way that represents the fashionable differential privacy, that's the most up-to-date standard in terms of anonymized data. What they do is that in a large data set, instead of, try to removing all these identifiers, so-called identifiers, they try to inject noise into the data set based on the mathematical proofs. They have proofs to do certain privacy guarantee. Under those assumptions, they injected the noise in that way. The hope is that even if hackers or other users, right, who happens to have that data set, because the data set already treated with those mathematically proved privacy guarantee type of noise, you have no way of linked back to the original natural person in that database. So this is the second group of data anonymization techniques, noise insertion, to guarantee the anonymity. So what we did is we have a real data set, right, with all the identifiers, and it's very intuitive. Data removal, like key anonymity type of procedure, actually reduce the variance because they try to remove the data set, some of the attributes. And then noise insertion types of data anonymization techniques, they increases the variance because they increase the noise in a way that it's so hard for you to identify the identities from this data set. And then we're looking into the different ways of doing disparity detection, because we get the context of the data in the health. And we understand that health disparity research is very important, right? It's a very important goal. You want to see certain treatment. Do they have equal treatment effects on majority population versus minority population? There are certain cases, life and death situation, that some drugs may have some special side effects on certain minority population. So we don't want to miss that. So health disparity detection, detecting those edge cases, that's special cases, right? Where that amount of drug will have a life and health type of effect on certain minority population. That's the most important goal in health disparity research. So we try to have the health disparity research as the important data analytics goal in this data set. And meanwhile, because of its health, we have to protect patient privacy. So we put these two together and see what happens. In this, I'm just using one example of one of the most famous approach for disparity detection. We realized that, when you apply the data with data removal procedures, because they reduce variances, and then when you try to do detection, disparity detection for these kind of anonymized data after, treating with data removal procedure, they tend to falsely report health disparity when in the original data set, there is no such disparity exist in the original data set, which means that after applying data removal procedure, we observe an increased likelihood of false positive or reporting health disparity. Well, when we do another technique in terms of data anonymization by insert the noise, right, by using differential privacy, we observed that false negative starting increasing. So think about this. If I say, this is a marketing context, the goal is to accurately predict everyone's preferences on certain products. And then we have consumer privacy protection. If I mislabel you as a lady and send you the lady products, that's fine. No tangible outcomes. You just feel annoying, irrelevant, you delete it. But if it's a health context, if you are unfortunately belonging to that minority population, would have very serious side effects on that certain drugs. And then I mislabel you as a majority population because all those identifiers were all removed, right? Because of patient privacy protection. And the data analytics products built on these data sets would lead to life and death outcome. So that is a message we try to deliver in this piece of paper. We're also going to, in depth in terms of health disparity. They have different techniques to do health disparity detection. And based on the different types of detection techniques interact with different types of data anonymization techniques, the false positive and false negative rates are completely different. Again, if it's marketing context, I don't care. But if it's a health situation regarding life and death, it matters. So the message, for this paper is that, we have to be very careful, right? When we put a one-size-fits-all type of legal regulations or framework or standards, we put them into the law. When we just say anonymization, but didn't quite understand the different consequences for different types of anonymization, different purposes of data analytics, then we have so many unintended consequences. And in this particular case, in health context, I would argue that GDPR backfires. But I perfectly understand it's so hard to do this. That's how, in my talk title, I say data, algorithm, people. I also add a policy piece. This exactly shows how the policy may lead to different consequences in terms of different types of industry sector. For marketing, perfect, fine. protect consumer privacy, right? And then reduce the liability about the company which holds the data, because once you know, if you have a breach, but if you anonymize the data, no one can identify natural person's identity anymore. So you perfectly protect consumer privacy. But then if it's a healthcare context, you would end up with some really serious consequences if you push the legislation in that way. Yes, I see you raise your hand.
Yeah, I had a quick question. It's fascinating topic. But I have one basic question, just a clarification in terms of GDPR. In healthcare research, GDPR, yes, it does apply to any consumer data that is used in marketing content and digital advertising. But does it apply to
No.
healthcare research as well?
Not exactly, not exactly. But this is just one example, right? Saying that putting any so-called privacy regulation, it may have intended and unintended consequences. But we happen to have access to a healthcare data set. So we try to, you know, we did this demonstration about, you know, for the data set, we apply different types of data anonymization techniques. And then we do a task, which is, in this case, we choose the task of health disparity detection and how we detect false positive and false negative differently, corresponding to different types of anonymization techniques. So the bigger question is, anonymization means different things. And when the authors of this legislation put this language there, say anonymization, they probably didn't understand that there are different ways of realize the goal of anonymization. I don't know how to do it. If I were the authors, can I have fine-grained level of details saying that if you are doing key anonymity, you should do this. If you are doing differential privacy, you know, type of data anonymization, you should do that. I don't think any law would have, you know, fine-grained level than that level. I'm not criticizing lawmakers. I'm just simply saying it's so hard. Yeah.
I think the main thing is you cannot generalize. It will be application dependent.
Yeah.
So when noise detection or other way, what are you looking for? That is important. If I'm looking for a certain kind of disease, a group of people, that's one. If I'm looking for a patient or other kind of racially diverse for a disease detection, that's a different goal.
Yeah, so that exactly justified the US privacy law systems, right? We in this country hasn't had the comprehensive privacy legislation yet. You know, European Union always very proactive about coming out or developing one-size-fits-all type of privacy legislation. US in this country will always have this patchwork section, you know, industry sector-based laws. Like in finance, we have finance privacy protection laws. In healthcare, we have healthcare. In the context of social media marketing, we haven't have any serious regulations yet in that space. I don't know which approach is better, but pros and cons. Yeah. Yeah, that could be a field experiment, right? We can see that, you know, US is so diverse that we have different types of legislative approach. And there are so many work in the privacy, even in the privacy law field, where people try to starting arguing whether privacy laws facilitates innovation or actually hurts innovation. That all, you know, comes with topics and discussions like this.
Can I ask you a question?
Sure.
There are a group of researchers and investors trying to all do this research for 6 months, right? So what's your opinion?
Well, my opinion. Well, first, I'm kind of surprised, right? Because usually in the context of United States, those tech firms are against any legislation. I mean, at least in the privacy landscape, right? The US government has been pushing self-regulation, right? Even there is regulation, it's often industry sector approach. If we have a problems in the finance sector, then there will be a privacy law. And if we think the population like kids under certain years old, they are more vulnerable. So we have a COPA law to just dedicate it, have more privacy requirements for the companies to collect data from the population under 13 years old. So in the health sector, I have been observing that the industry in this country favor this more industry customized approach. They don't want the one-size-fits-all legislation. And it's quite surprising that big tech firms, you know, the leaders, CEOs, and get together, try to advocate a comprehensive AI legislative framework. There might be other business motives. I don't want to, you know, guess. Is it good? Maybe. But everything, there is no perfect solution to this. If they push for one-size-fits-all legislation, there might be unintended consequences when you enforce one-size-fits-all standard across different industry sector, across different populations in this country. So
It's hard to change because of this sudden disruption in workforce.
Okay.
Sudden disruption in creativity, right? So all these AI-based things, you can create music, you can make movies, you can write poetry, and everything it seems to be touching every aspect of human workforce. So I think there has to be some, some changes for it to come.
yeah, I think we're at a very interesting time. Maybe we can finally relax everyone from some tedious labor-intensive jobs. Finally, we can let machines to take that part so that our space can be, you know, our attention and trainings can be more devoted to predict.
Then what will happen to the people in the labor?
We retrain them to do something like the cleaning crew, right? Instead of clean every single inch of these huge and giant buildings, they become a supervisor. They check the quality of the clean by these machines. And then they use handheld devices to clean those tiny square footage where the machine failed to clean. Isn't that nice? That they don't need to spend 10 hours in clean every single corners. They only need to have a handheld devices to walk through the building. Within 1 hour, they can perfectly clean every single corner. So we retrain them instead of working for 10 hours. Now your job is to just very dedicatedly look around each single corner to clean those leftovers that machine failed to clean. That can be 1 hour job. Yeah. And we retrain the other 9 people to do probably other types of jobs that need some other type of skills that AI cannot do it. Or we need a verification for those AI systems. For example, can we, if imagine that Tesla, that business really takes off and everyone is driving and utilizing self-driving mode on your Tesla cars. For those security attacks I showed it to you, I think we really need, some human to verify each single of those traffic lights and traffic signals, right? What will happen if some just naughty teenagers to put some random stickers that can mess around the traffic controls and may threaten people's lives?
And those are called adversarial attacks.
Yes.
Those things already happen. Silence public transit. What's the data about that?
Well, that's what we just talked anniversary machine learning. So you try to understand how machine recognize patterns, and then you engineer, those noise and try to fool the machines. I think it's also a growing space in the cybersecurity technical research community. They try to do cyber and machine learning, but in the other way, in the opposite way, right? To predict what kind of attacks may be engineered in that space. They also try to leverage this easy thing that they recognize as what kind of things can easily trick the machine, but can satisfy humans' eyes. That's where the vulnerabilities are, right?
And I'm also talking about the AI and the human specificity, the interaction between one another. That's where the Chinese transit system comes, where this human is sitting and making sure the bus, which is, say, in Shanghai, it's an AI or a self-driving bus, but there is one human who's sitting there, just making sure everything, is supposed to be the way it should be.
It's like the aircrafts, right? The pilots, it's actually, most of the times it's autopilot. And the pilots are there just for the communications with the airport when it's close to the destination. And most of the times, it's autopiloting mode. Maybe our cars can function that way. So we reduce certain frequencies of human mistakes and errors. Hopefully we can reduce the traffic, jams and, reduce certain likelihood of the accidents. That's our dream, that's our vision. But in order to get there, there are so many human factors, society norms and legislations, and how we can ensure the safety. That's all challenges. Yes?
I'm just curious about the data that you have. So is it from the United States or is it from European Union?
United States. Yeah. Okay. So what I did today, you can see that I'm still doing privacy research. I still feel I'm a privacy researcher. But when I started engaging with different pieces of privacy research, I started feeling that, there are trade-offs, right? When we talk about data anonymization techniques to protect privacy, we heard the utility of the data. We heard the validity of the data analytics products we are going to build from those data where we treat it with data anonymization techniques. That's a trade-off. As I mentioned, in certain contexts like marketing, sacrificing the validity and accuracy of a prediction models to protect consumer privacy is perfectly fine. But then this pair of trade-off may not be fine in other contexts. That's the message I try to share. And privacy fairness, you also see, right, from the same example, right, in terms of disparity detection, the minority, if you think, minority are more vulnerable to be identified from this data. So we try to put one size fits all type of solution to equally anonymize the data, no matter where you are from, minority population or majority population. That actually hurts the benefits of minority population when we talk about health disparity research. But of course, in marketing context, could be fine. We can sacrifice a little bit of prediction accuracy, right, to protect the larger base of the consumer privacy. Fairness and validity, sometimes, we want to be fair, to build fairness constraints in the algorithms. And we also notice that the validity or the accuracy of the prediction model may be sacrificed along that way. So my point is, even for my own research, these three goals, when you look at them independently, no one would argue with me that any of the goal is evil. We will see these are good values, right? We value as a society. But in certain contexts, in certain kind of task we try to do, they contradict. And you cannot have all. At those situations, how you are going to make the trade-off? You sacrifice privacy to get more fairness? Or you sacrifice validity to get more privacy? Who should make that trade-off? under different situations. And I hope we can do all. But my research right now, in collaboration with IO psychologists, management scholars, computer scientists, we are constantly making different trade-offs among these three goals, which make me feel frustrated. And this is just three goals. If you take any big tech firms, their AI governance models, principles, read their frameworks. Each single line of their principle out of that 100 checklists, each one of them are so beautiful. But I bet in their engineering team, some, if you try to realize and implement some principles you put in that beautiful framework, may hurt or make other principles listed on the same document harder to achieve. So how we are going to solve that? Who should make judgment call? What's considered as fair? We don't know. So I'm just basically sharing my frustrations with all of you. And I want to show you that it's very easy to criticize today's AI development. It's not perfect technology, but it's really hard. And believing me, there are so many technologists who want to achieve all, but sometimes there might be technical feasibility limitation. There might be other limitation that we just cannot having all yet. We need patience. We still need hope. We shouldn't label all the AIs as evil development, right? We need time to fully get there. And I truly hope we can achieve all. But right now, it's just, we're making trade-offs. Yes?
You want this example of anonymization and fairness and the minority population. Can you give me an elaborate example? The struggle I'm having is typically these anonymization techniques are applied only on the identifier variables. Right? For example, let us say if there is a record of me somewhere. As long as my identifiers, like let's say the SSN or my name is taken off, the rest of the data can be used, however, as it fits. So if you can give me a tangible example of where the struggle between anonymity and fairness comes, especially as we talked about the minority population. Because the attributes that decide who a minority is, I don't think those variables are actually hidden, right? For example, be it the race, or be it gender, be it whatever the case in point, that is not identifying information. Right?
What? It is identifiable information. It is. So by today's standard, you have to raise age, because age can infer your birth date, right? And your names and your race. You can't share those data. So by anonymization technique, you have to remove all those.
Race and gender as well?
Yes.
But then that is not PII at all, right?
They are PII. They are personal identifiable information, especially for minority population. Think about how sensitive race is.
Yeah, but see, the fact that if my name is taken out, people won't know it is me they're talking about.
Oh, no.
No, they can't.
No, in the, yeah, even before machine learning and anniversary machine learning, we use old techniques. We can simply, based on the date of birth, gender, and your zip codes, and uniquely identify 87% of Americans in this country. So if you're looking at them alone, gender, you don't think it's personal identifiable information, right? Yeah, of course, I agree with you. But gender adding zip code in combination of date of birth, they can identify you. So if you say it's just each of these three variables alone, yeah, it's not personal identifiable, but adding them together in combination, they become personal identifiable attributes to identify 87% of the Americans. So that is just the old techniques, and today is more accurate than this. Yeah.
In the fairness part, you talked about engineering for intentions versus engineering for goal achievement, right? So, leaving all this AI stuff aside, I mean, in the MIS field, for a long time, and even now we have been talking about the gap between intention and actual behavior, right?
Yeah.
Isn't that an artifact of, I mean, because we were talking about intention of human beings, but here it's the intention of the machines and how they behave, right?
Mm.
So, and when you can't measure the intention of the machines, so obviously you can't predict the behavior. So, isn't that just an artifact of?
I think, yes, you perfect say even in the human psychology space and behavior, we can't fully understand the gap yet, not mentioning about AI. But that's a perfect simple example, right? To illustrate how hard it is. We shouldn't overly criticize, AI community is doing a bad job. Right now, the gap that actually reflected on a lot of shocks and technological surprises we have been seeing. Sometimes that's so scary, right? Like the large language models, for example. Those large language models, the intent was to give them billions of records of text, right? So that they can predict, when in combination of the forwards, they can know they can predict the next phrase you're going to say, right? That's how this, ChatGPT, the interactive features is all based on the training of huge amount of the text. But the unintended behavior, or in the computer science language called emergent behavior, is that suddenly you just give the data of the text, right? You train this machine to have intelligence in terms of how to interact with you, training a chatbot. But now you give them a task asking, what is 1,995 plus 999 equal to? They can make a calculation. So that's the technological surprise we are facing now, right? Of course, they surprisingly have certain unintended intelligence. So we are training them to recognize letters, words, phrases. Now, we never train these machines to have calculation capacities and to do math, but suddenly they can. How to explain that? And that's where the fear comes from. If you train them for text, now they know how to do calculations. What other, maybe some not so right things, the evil capacity they may have that is out of our prediction and out of our control, that deviate from the designer's true intent? I would say that is where the fear comes from. But that also speaks to the exciting part, right? How you can imagine that I try to teach my 5-year-old to do spelling. I never teach him to do calculations such as 100 plus 499. And suddenly he know how to calculate without me teaching that. How you would recap that? You're shocked. When you're shocked, you may sometimes have fear. What will happen if he knows how to kill a person, right? That's the fear we are now. And that's also exactly, I try to explain what the AI is with two of my boys, and they had exactly the same fear. And they asked me the question that I feel it's really hard to answer. They asked me, Mom, do you think AI is smarter or humans are smarter? And I'm telling them that right now, I still believe humans are smarter, but after 10 years, I don't know. Because we can't explain when we teach them how to recognize letters, and then suddenly they have the capacity to do math. And I can't explain. And then my 9-year-old asked, then if they are really smarter than humans, will they kill us? I think these are the really philosophical questions, right? And we don't want any of those to become reality, but we don't know. And these, I just feel that the time, the uncertainty, the unknowns we are facing in this phase of AI development is surprising, is in shock. And I guess that's the reason why some of the technological firms maybe want to put some kind of task force together to pause the AI development and to revisit and to see whether we can build some frameworks to guide and to prevent those harmful consequences, right? And that is a scary part, but it's also, how people can explain those unexpected intelligence these models get, where they never feed the data about math calculation. They were fed with the data with huge amounts of text, phrases, novels, Shakespeare's. And we train them to write a novel, but suddenly they know how to do calculation. I feel it's a little bit scary. That's why people can have fear, right? And newspapers have a lot of discussions on that topic as well.
I think we have a couple of questions in the chat.
Oh, great. Yeah, so I can. Knowledge-centered privacy concern. Okay. Is there any way to measure the risk of such disclosure? Well, so this question is from Yuan Yuan. Yeah, so Yuan Yuan asked a question about in the knowledge-centered privacy AI language model capacity, individuals still disclose their information, even private information online for various reasons. Is there any way to measure the risk for such disclosure? I guess that question applies to measure the AI risk, unintended consequences behavior as well. I would say that's a multi-billion-dollar question. I don't know. And maybe the community will figure out the measurement of the risk, the assessment of risk. If people figure out, if the Silicon Valley figure out, and then the AI can guarantee certain amount of safety, security, and privacy, and then we can resuming the bright future of AI development. So thank you for the question, multi-billion question, where everyone working in Silicon Valley truly cares. Another question, can we use in AI training data sets to ensure that models do not memorize data, especially outliers? I don't think so. They memorize everything. They take everything in. So that probably a question that, the state of art, those professors, computer science professors in University of Pennsylvania who are working on machine learning, they just try to see whether the models after trained with the original data sets, is it possible and feasible if we remove certain original data set, the algorithms can forget the influence and the contributions of this data on that models. It's still, I would think, when people put a proposal together, they can easily get a 20 million research projects from National Science Foundation because it's a state of art. No one figured it out yet. But I stay hopeful. I'm not working in that area, but I follow those research and I try to just stay curious and see which team out of all the frontier project National Science Foundation fund 5-year, $20 million, they can figure out that kind of question. Memorization seldom leads to security leak. For that, we need to go for machine learning. Oh yeah, it's just so hard to realize, to just implement the unlearning part yet. Yeah, these are all the questions. Others are comments.
Any more questions? Okay, thank you, Professor.
Thank you, everyone. Thank you. Thank you. I mean, I share a lot of my questions instead of giving an answer. So I know sometimes